Hello everyone, welcome back to Pharmacy Made Easy. Today let's discuss about alligation method. And this is one of the important area of quantitative aptitude for various competitive examination. The rule of alligation that enables us to find out the ratio in which two or more ingredients at a given concentration must be mixed to get a final mixture of desired concentration. It also helps us to find out the amount of each ingredient needed to make a mixture of given quantity. Okay, so this alligation, this is one of the simple and illustrative method in pharmacy. So now let's see what is the difference between dilution and alligation. Alligation method and dilution method, these two are different methods but not completely different. There are little bit difference between these two methods. So now let's see what is dilution. So dilution, that is a simple method and it is mainly used for calculating or preparing a lower concentration from a higher concentration. Or otherwise, this dilution method that is mainly used in case of the solvent, when we are using water as a solvent. In that case, we are mainly using this dilution method. Now let's see an example for this dilution method. Just consider you have a 10 molar solution, and from this 10 molar solution you have to prepare a 5 molar solution, or you have to prepare 50 ml of 5 molar solution. Okay, so from 10 molar solution, this is concentrated one. From this you have to dilute it into 5 molar solution, 50 ml 5 molar solution. Now we have to calculate the quantity of 10 molar solution that should be taken for this dilution. So in this case, this is a simple calculation. So for this case we are using dilution method, and here we can use the formula M1V1 that is equal to M2V2. So this is a simple dilution. Okay, so here M1, that is the molarity of the first solution, then V1, that is the volume of first solution. So in this case we have to find out V1, and M2 the molarity of second solution, and V2 the volume of second solution or final solution, final concentration. So here 10 into V1 that is equal to 5 into 50. So V1 that will be equal to 5 into 50 divided by 10, that will be 25 ml. Okay, so we have to take 25 ml of this 10 molar solution for diluting it into 5 molar solution. Okay, so this is a simple calculation and this is all about dilution. Now we are coming to alligation method. So alligation method is used to solve problems that involve mixing of two products of different strength to produce a product having desired intermediate strength. For example, we are mixing a solution with X percentage and Y percentage in order to get final concentration of Z percentage. So in this case we will use alligation method. So in calculation part you can see some problems which involve the solutions which should be mixed at specific proportion in order to get the required concentration. So this cannot be calculated by using the simple dilution formula. So here we have to use the alligation mathematics. Okay, the proportion of these two solutions that should be mixed, and we have to calculate the ratio at which these two solutions should be mixed. So that is the basics of alligation rule. So first let's see how to solve the alligation problems, then we can see some examples in detailed way. So then you will get an idea how to use this alligation method. Before going to the different steps involved in this alligation method, first we have to go to the main part of this alligation. Okay, so for that, suppose we have to prepare a solution with certain percentage concentration or strength by mixing two different solutions of strength X percentage and Y percentage. Okay, so among this X, that can be considered as a higher concentration, and this one Y, that can be considered as a lower concentration. Okay, so now let's see how this X and Y, or in which ratio this X and Y should be mixed in order to get a solution with concentration or percentage Z. Okay, so before going to this one, let me remember you one thing. In alligation method, there is one rule, that is the solvents like water or diluents, for example some ointment, cream, bases, etc. So in their case, the percentage strength, that is considered as 0. Okay, because there are not any active ingredient present. So in their case, we are taking the percentage concentration, that is 0. So we can see some questions involving this rule in later. So first we can see the general topic, that is the general alligation method. Okay, so here once again we are making third percentage concentrated solution by mixing 2% strength, that is X percentage and Y percentage. Here X is higher concentration and taking Y as lower concentration. So in alligation method, the first step, you have to draw a alligation matrix or alligation grid. Then the second step, you have to write the higher concentration in the top left corner of this matrix. Okay, so in the first step you have draw a grid. In the second step you have written the higher concentration in the top left corner. Next you have to write the lower concentration in the bottom left corner. Okay, so first you are drawing one grid or matrix, then you are writing this higher percentage strength in the top left corner, then lower concentration in bottom left corner. Then write this desired concentration in the center of the matrix. Okay, so first you have written this higher concentration, then lower concentration, then desired concentration at the center corner. Okay. Now you have to find out the difference between the percentage strength, that is the required percentage strength, that is the middle column, and the lower concentration, lower percentage strength, that is the bottom left column, in diagonal way. Then you will find out it as Z minus Y. So the difference between the middle column and bottom left column, that is written diagonally in the opposite side, that is in the top right column. Okay. Now we have to write the same thing in this way also. When we are calculating the difference diagonally, so we are finding the difference between the higher percentage strength and the desired percentage strength. So that will be X minus Z, that we have written in the bottom right corner of the alligation matrix. These two values, so here we find out the parts. Okay, so now the amount of difference that you found out here, this became the parts of the percentage directly across the grid. Okay, that means here we can call this Z minus Y as A. This is just for our convenience. We are calling this Z minus A as A and this X minus Z as B. Okay, so this is just for our convenience. So the difference between this Z and Y, we call it as A, and the difference between X and Z, that we call it as B. Okay, so here we have find out A parts of X percentage and B parts of Y percentage. Okay, so this is how we are calculating the parts. Now if we have to find out the ratio, that means the ratio between X and Y, that means X is to Y, the ratio that is equal to A is to B. Okay. So first, in alligation method, we draw one alligation grid or alligation matrix. Then we have written the higher concentration here, the lower concentration here, and the middle concentration or the desired concentration in the middle of the grid. Then we have find out the difference between the middle concentration and lower concentration. We have written the same in here, that is the top right corner, and also the difference between higher concentration and middle concentration in here. So we have written the difference values in diagonal way. Okay, so here we have written the difference, and also this difference we have written here. Okay, now the straight values, that the value corresponds to this x, we have find out z minus y, or we can simply call it as the value A. Okay, so here A parts of x and here B parts of y. Okay, so in order to get the z percentage, we have to mix A parts of x and B parts of y. So this is the basics of alligation method. So usually the questions will be like, in which ratio you have to mix these two strength or percentage concentration. Okay, so the ratio will be A is to B. That means the difference value that we have written here. Okay, so this is how we are finding out the ratio in alligation method. Okay, or the proportion that in alligation method. Now let's see how to calculate the quantity. Exactly how much quantity. So if a question came like, how much quantity of A should be mixed with this much ml of, for example, how much quantity of 5% solution should be mixed with 100 ml of 10% solution in order to get 15 ml of 7.5% solution. So in that case, we have to find out the exact quantity. Okay, so how to find out such quantity? So now let's see how to find out such quantity. So that will be the second type of problem that can be asked in alligation method. Okay, now the question before us is how to calculate the exact quantity using this alligation method. So now we know we have to mix A part of x percentage and B part of y percentage. Then we will get a concentration of Z percentage and the final volume or final concentration. That will be, just consider it is C. Previously you have seen a higher concentration of x percentage and lower concentration of y percentage that mix in order to get a final solution of Z percentage strength, and the ratio that you have already find out, that is A is to B. Now the question, we are coming to the question, how much quantity is required from this x and y, or this higher concentration and lower concentration. So for that also there is another equation for that. So for that first formula, the quantity of higher concentration, that is equal to A divided by A plus B into V, and this V, that is the concentration of final solution, or you can either written it as W, that can be either volume or weight. So in this case I am taking the case of solutions. Okay, so here instead of this quantity we can write it as the volume. So the volume of higher percentage or higher concentration, that can be calculated here using the equation A divided by A plus B. So A, that means the part that correspond to higher concentration, and the total parts, so A plus B into the final volume. So using this equation we can calculate the volume of higher concentration, how much ml of higher percentage should be used for getting that final concentration. So similarly, in order to find out the volume of lower percentage, that will be equal to, instead of A, that will be B. So B means the part that corresponding to the Y percentage or the lower concentration divided by A plus B into V. So that will be similar to this equation, only difference is here we will be using B. That means the difference that corresponds to the lower concentration or the lower percentage. So by using this equation you can find out the exact quantity. Okay, now let's see some examples for this alligation method, so you will get a complete idea how to use this equation. Okay. Once again, this alligation formula that can be used, first one for find out the concentration or the ratio or the proportion in which two solutions should be mixed in order to get solution with the final concentration or final strength. Okay, and the second use that is we have to find out the exact amount in which the two solutions should be mixed in order to get the final concentration. Okay, so once again here I am using this equation in case of solution, but if the same question asked in case of other forms, like in case of ointments or creams, instead of this volume you can use their weight as a standard. So according to their creams and ointments, the equation will be the weight that will be equal to A plus B into the weight in final solution. So in that case you can use weight instead of volume. So that you have to use according to the question. Okay. So now let's see some examples for alligation method. First question, how many parts of 10% weight by volume solution and 4% weight by volume solution should be mixed to produce 8% weight by volume solution? So here the first step, that is analyzing the question carefully. Okay, so from the question we can find out the higher concentration, that is 10% weight by volume. Then the lower concentration, that is 4% weight by volume. Then the final concentration, that is 8% weight by volume. Okay, so in the first step we have analyzed the data. So from that, the higher concentration, that is 10% weight by volume, lower concentration 4% weight by volume, then the final concentration or desired concentration, that is 8% weight by volume solution. Now let's come into the second step. So in the second step you have to check whether the units given in the question, they are similar or not. So here the higher concentration expressed in weight by volume, then lower concentration that's also expressed in weight by volume, then final concentration that is also expressed in weight by volume. Okay, so there is no need for any conversion. Okay, so all these three are given in similar units, so you don't have to convert it into another units. So in case if these are different, you have to make all these units similar. So after that you can use alligation grid or alligation matrix. So that is our second step. So in the first step we have analyzed the data. Second step, check for any conversion which is required or not. Okay, now let's coming to the third step. So in the third step we have to draw the alligation grid. Okay, so we have draw the alligation grid here. So we know the higher concentration, that is 10%. So higher concentration we have written it here. Then lower concentration that we have written in the bottom left corner. Then the desired concentration or intermediate concentration that we have written in the middle of that alligation grid. Okay, now we have to find out the difference diagonally. So first of all we are finding the difference between these two values, and that will be 10 minus 8. And we can write the value here. Okay, now we have to find out the difference between these two values, and that will be 4 that we have written in here. So we have find out the difference here, and also here also we have find out the difference. Okay, so I already said when we are writing in terms of parts, that will be 4 parts of 10%, then 2 parts of 4%. So we will be written it as 4 parts of 10%, that is the higher concentration, then 2 parts of 4%, that is the lower concentration. So the ratio, the alligation ratio will be 4:2. So the alligation ratio will be 4:2, or we can written it as 2:1. Okay, so here the question was how many parts of 10% weight by volume solution and 4% weight by volume solution should be mixed to produce 8% weight by volume solution. So the answer will be 4 parts of 10% solution and 2 parts of 4% solution should be taken in order to get 8% weight by volume solution. Okay, so the ratio will be 4:2 or 2:1. Okay, so here in the first step we have analyzed the question carefully. In the second step we have checked for the units and we have checked whether any conversion is needed, and in the third step we have applied the alligation grid or alligation matrix, and in the fourth step we have find out the parts, number of parts. Okay, so this is one type of the question that can be asked from this alligation portion. Now let's see another example. Second question, how many ml of 1:20 volume by volume solution of a drug can be prepared from 100 ml of 6% volume by volume solution? Okay, so we are coming to our first step. We are analyzing the question. Here in this question, the dilution solution that is not specified or it is not given, so we can take it as water. Okay, so we are mixing water and also the 6% volume by volume solution. And in the starting of this video I have said that in alligation method the solvents, the percentage strength of solvents, mainly in case of water we will be taking it as 0% weight or 0% strength. We will express it as 0% strength. Okay, so here the higher percentage strength, that will be 6%. So in the first step, higher concentration, that will be 6% volume by volume. Then lower percentage, so this lower percentage will be that of water. So here we are using water as a diluting solvent. Okay, so in this question the diluting solvent is not specified, so in that case we can assume that will be water, and in case of water the percentage strength that we will use as 0% volume by volume. Okay, so the higher concentration, that is 6%, the lower concentration 0% volume by volume. Now another thing, the required concentration or desired concentration, that is 1:20 volume by volume. Okay, so in the first step we have written higher concentration as 6% volume by volume, then lower concentration, that is 0% volume by volume, and the required concentration, that is 1:20 volume by volume solution. Okay, so how many ml of this 1:20 volume by volume solution should be prepared from 100 ml of 6% volume by volume solution? So that is the question. Okay, so we have to find out the final volume of solution with strength 1:20 volume by volume. So that is our question. Okay, so we have done our first step. Second step, we have to check whether the units are same or not. So in higher concentration, that is expressed in volume by volume, and second one, that is expressed in percentage volume by volume. So these two are same. Now we are coming to the unit of the final strength, that is expressed in 1:20 volume by volume. Okay, so here these two expressed in percentage volume by volume, but in final concentration, that is just expressed in volume by volume only, and also 1:20 volume by volume. So we can convert this into percentage volume by volume. Okay, so here the final concentration, that is expressed in terms of ratio, that is 1:20 volume by volume. So we have to convert this into a percentage strength. Okay, so here 1 ml of drug, that will be present in 20 ml of solution. So 20 ml solution contain 1 ml drug. So in order to find out this one into percentage, we have to find out how much quantity that is present in 100 ml of solution. So in 100 ml, the quantity of drug, that will be 1/20. into 100 and the answer will be 5 ml. So in 100 ml solution, the quantity of drug is 5 ml. So the percentage strength of this final solution, that will be 5% volume by volume. Okay, so 5 ml dissolved in 100 ml of the solvent. Okay, so we have found out the concentration or the strength of the desired concentration or the final concentration as 5% volume by volume. Now these three units are similar. Okay, so our second step is also completed. So in the first step we have analyzed the data, and second step we have converted the units into a similar one. Now let's come into the third step, that is we have to draw the alligation grid. So we are drawing the alligation grid here and we are substituting the values, the higher concentration or higher strength that we have written here and the lower strength that we have written here, then the desired strength that we have written here. Now we have to find out the difference and we have to write it in the right portion of the alligation grid. So here the difference will be 1 and here the difference will be 5. Okay, so the ratio will be the ratio of or the alligation ratio of higher percentage versus the lower percentage, that will be 5:1. So 5 parts of 6% solution should be mixed with 1 part of 0% solution. That means 5 parts of 6% solution mixed with 1 part of water in order to produce 1:20, or here we have find out into percentage, that is 5% volume by volume solution. But here the question that was how many ml of 1:20 weight by volume solution that is prepared. Okay, so here the question is how many. So we have to find out the quantity. Okay, so in this question we have find out the ratio of higher percentage and lower percentage, that is 5:1. Okay, so previously we have explained how to determine the exact quantity. So from that we can find out the final volume of that solution, that is this 1:20 volume by volume solution. Okay, so for that the volume of higher solution, that is equal to, we have written previously that like A divided by A plus B into W. Okay, so here this is A and this is B. Okay, and the volume is already provided, it is 100 ml. So 100 will be 5 divided by 5 plus 1 into W. This W we have to find out. So that will be equal to 5 divided by 6 W, and W will be 6 into 100 divided by 5, and the answer will be 120 ml. Okay, so first we have draw the alligation grid and then we have calculated the quantity of the final solution prepared. Okay, so here how many ml of, so we have find out 120 ml of, instead of this 1:20 we can written it as 5% volume by volume solution. So 120 ml of 5% volume by volume solution can be prepared by using 100 ml of 6% volume by volume solution and water. Okay, so this is the second type of question. So in the first question that was a simple calculation, just calculating the ratio, and in the second question we have find out the exact quantity. Okay, I think these two methods are clear. Now let's see another example for the same. So third question, in what ratio 1% and 2.5% ointment should be mixed to produce 120 gram 2% ointment? Okay, so till now you have seen two examples that mainly involve liquids or solution. So here you can see an example for a solid. So mainly this question can become associated with ointments or creams. Okay, so here in what ratio 1% and 2.5% ointment should be mixed to produce 120 gram 2% ointment. So here also we are using the alligation method. So here in the first step we are finding the higher concentration, that is 2.5%, then lower concentration, that is 1%, required concentration or desired concentration, that is 2%, and in the second step we are checking the units and all those things are similar. So we are moving to our third step. We are drawing the alligation grid and we are writing the higher concentration here and lower concentration here and the desired concentration here, and we are calculating the difference. Then we will get here 0.5 and here 1. Okay, so 1 part of 2.5% ointment and 0.5 part of 1% ointment should be mixed in order to get this 120 gram 2% ointment. So here the question was about the ratio. So the ratio of 2.5% ointment and 1% ointment will be 1:0.5. Okay, and in case of DHA, MOH and HAD exams, you won't get any paper for practicing or calculating this in this much detailed way. Okay, so you have to very thorough with this calculation. Then you can calculate it very easily without using any paper or anything. You can just minus or just find out the difference from these two values, and then you can directly write the answer easily. Okay, so for that what you have to do is you have to practice at least 5 or 6 questions from this allegation part on, because you can expect at least one question from this allegation part. So for that you have to be thorough with this allegation topic. So for that what you have to do is you have to practice the questions very well. Okay, so then you won't require any paper for practicing or for writing these steps this much elaborated way. Now let's see the last question of this alligation method. In what ratio SWFI, that is sterile water for injection, should be mixed with D10W, that is dextrose 10% weight by volume solution to prepare 500 ml 7.5% solution? Okay, so we are coming to the different step. In the first step we have to analyze the question. So in what ratio you have to mix the sterile water with dextrose 10% weight by volume solution? So in the first step, the higher concentration, that will be D10W, that means 10% weight by volume solution dextrose. So here that will be 10%. Then the lower concentration. So I already said in alligation method the percentage strength of water should be 0. So here we are using sterile water for injection as solvent. So its percentage strength will be 0%. So we are writing it as 0%, and the required concentration, that is 7.5%. Okay, and the units are expressed in similar way, so there is no need for our second step. Now we are moving to the third step. We are drawing the alligation grid. Then we are writing the higher concentration, then lower concentration, then intermediate concentration. Then we are writing the difference here. So this difference we will write in here, and it will be 2.5, and here that will be 7.5. So the ratio will be 7.5. The ratio of higher to lower, that will be 7.5 is to 2.5. So in what ratio? So 7.5 parts of dextrose 10% should be mixed with 2.5 parts of sterile water for injection in order to get 500 ml 7.5% solution. Okay, so this is all about alligation method. I think this method is clear for you. In case if you have any doubts, you can ask in the comment box given below. And now it's your turn. I will provide some revision question for you. Please go through those questions and try to give answer. First question, how much quantity of 10% cream and 5% cream should be used to produce 120 gram 2.5% cream? Okay, so here you have to find out the quantity. Okay, so this is the first question. Second question, in which ratio 1:25 volume by volume solution and 1:500 volume by volume solution should be mixed to get 1 liter 1:250 volume by volume solution? Okay, so these are the two revision questions for you. So this is all about alligation method, and alligation method, this is one of the important tool in pharmacy field in order to calculate the final strength, or in which concentration or in which ratio two solutions should be mixed in order to get a final concentration or final strength. Or this also can be used in order to calculate exactly how much ml or how much amount or weight or quantity the ingredients should be mixed in order to get a final product. Okay, so this is one of the easiest method, and once again this will be very useful for those who are studying in B Farm and also D Farm, and also this will be helpful for those who are writing various competitive examination, because this is one of the question which can be asked very frequently. Okay, so if you practice these questions repeatedly, then you can calculate the answer very easily without using any paper. You can calculate it simply by looking into the question itself. Okay, because in some exams like DHA or MOH or HAT, you won't get any paper for practicing or for calculating the answers. So you have to calculate it, that one in your mind. Okay, so for that you have to practice this method very well. Okay, so whatever the calculation, you have to be thorough with that topic very well in order to calculate it in your mind. Okay, so this is all about alligation method. I hope this section that was easy for you, and if you have any doubts, please ask me in the comment box. And thank you for watching my channel, and if you like this channel, don't forget to like, share and subscribe. Thank you.